ask you guys two questions. One of them is like, what is the most stupid question that you have ever come across? Anyone? Yeah? Okay. Anything much more stupid? So the most stupid question that is going to be is asking no question. Okay. So throughout the entire session, if you guys have any doubts or you don't understand any topic, because this is a very vast topic and I have tried to take out chunks of it. So if you guys don't understand any part of this session, do interrupt me, feel free to interrupt me, okay? And also, like, before we start, I'll be showing you guys the parts of the session, what heavy on theory, what is Active Directory, how the things function, just a bit of intro so that you can get started with the attack, like how the Kerberos or NTLM based authentication mechanism works. And so the next question is, like, how many of you have come across Active Directory or know what an Active Directory is? Yeah. So I guess there are a few working in the enterprise, they know about the Active Directory, but how many are students over here? Can I get a hand raise? Okay. So, coming to who am I? Basically, I'm a CTF player. I am also an offensive security researcher, and apart from that, like, if you guys are into CTFs, you guys have probably known me. I also hold OSCP, CRTP, ECPPD V2, and also currently I'm working towards CRTO. So, like, this session has been comprised of parts and chunks of all those things that I had learned during those, like, certifications. So, like, as I was asking, what is Active Directory and why this session? So, this is the reason. Everywhere you go, you are going to see Active Directory in an enterprise environment. So, what is Active Directory again? Active Directory is nothing but it is the directory services of Windows. And what I mean by that is, like, it was introduced back in the year 2000, and it was essentially introduced to manage everything, like the entire organization, all the data in the like an organization. It was being managed by the Active Directory. Like, in an Active Directory, you have got a domain controller which handles each and everything, like authentication, then authorization, and then you have group policies that you apply to an object. Active Directory also has got DNS roles installed in them. Also, in the Active Directory, you will be finding that there will be multiple domain controllers that handle the replication rights among themselves. Also, there are, like, when there will be multiple domains, like there will be root domain, child domain, external domain, then the concept of trusts are going to be introduced in them. And just keep this line handy, that everything in an Active Directory is going to be an object. So that's it. And coming to, again, some of the key components, when you interact with an Active Directory, you are going to encounter domains, domain controller, organization units, folders, trees, domain user, group policies, what are containers, schemas, etc. Next slide. So again, this is a visual representation of what an Active Directory is before we move to the next part. Can you guys see it at the back? Can you guys see it? Okay. So here is a diagrammatic representation of what an Active Directory is. So consider there is an organization red, and then there is an organization named blue. Okay. Red handles the red teaming operations and blue handles the blue teaming operations. All of a sudden, this red organization, this has acquired this blue organization, okay. And now the employees, like, red has got two branches, US.red. Like US department, and one department is in UK, okay. And one of this, their headquarters is somewhere else, probably in India or somewhere. So what you can see is, you have got an organization, right? Red.local, that is going to be that offices network. And then again, like, people from red.local or that organization in India want to access resources in US or want to access resources in UK. How are you going to handle? Like, with Active Directory sitting here in India, you can even log into or access resources in the UK, or UK people can log into the resources and access resources in India, provided you are given the authorization to do so. Okay, so those are defined in the group policies. And so, like, or the top level domain that you see over here, red dot local, this is going to be the root domain. Okay, this is referred to as the root domain or the parent domain, and below that, like following the same naming conventions, like you had red dot local, you added some certain part, but then the domain component remains the same. That is red dot local. So this us.red.local, this is a child domain of red.local, and uk.red.local is another child domain of red.local. Okay, and when you have a parent domain and a child domain, what comes in is a bidirectional trust. Okay, there is a bidirectional trust between this parent domain and a child domain. This is important for you guys to know, because since you compromise even a child domain, a domain controller in a child domain, and if there is bidirectional trust across the entire forest, so suppose you compromised a domain controller in a us.red.local domain, and there is a bidirectional trust across the entire domain, so you will, from here us.red.local, you will be able to compromise each and every resource, each and everything inside red.local, uk.red.local, blue.local, and dev.blue.local. So the entire forest or the entire organization can be compromised. We are going to see how easy it can be. Like certain misconfigurations can lead to those. Also, there is this forest. So forest is a security boundary, and these red.local, these are generally referred to as leaf or forest root nodes. Also, when you have a bidirectional trust of parent child, this is referred to as tree, and when you connect these trees with something external, then it becomes a forest. Okay, next slide. So yeah, as I was mentioning there, these common components are there, the active directory data store, domain controllers, so on and so forth. We are going to have a look at each of them. Yep. So let's get started. So again, the main thing you need to know about the Active Directory data store is, everything I mentioned in an Active Directory is stored in a database file, right? And that database file is ntds.dev. This file is stored by default on the Windows NTDS path in the file name ntds.dev. And even in a red team operation or in an Active Directory attack, if you are able to get hold of this ntds.dev file, and it's a game over. This is essentially a crown jewel, what we call in red teaming as well. And then these are some common partitions, as I was naming, that domain, you can have domain components. You can component name, if you define schema under the domain component of domain com, then it becomes the schema partition. Similarly, there are configuration partitions where you essentially store the schema objects or the configuration objects. Okay, in the configuration partition, you have the structure and attributes of the components in the forest, and in the schema partitions, you will be defining how the entire object schema or the structure is in the forest. Okay, next slide. Yeah. Then as we know, domain. So what is a domain? Consider the previous example that I gave you, that Red has an office in India, which is red.local. Okay, so in that organization, you will be having multiple users. There is going to be a domain controller or a server. Now there are going to be a single domain controller, or there could be multiple domain controllers. The reason for multiple domain controllers is you need a fail-safe mechanism. If you guys, some of you are into AppSec, you guys, or application development, you know that as a fail-safe mechanism, you keep a load balancer, and then you have got multiple server as a fail-safe. So in case one of the server goes down, the load balancer will handle the request as a fail-safe mechanism, right? Similarly, in an Active Directory environment, just for fault tolerance and just to avoid the latency, what we do is we have got multiple domain controllers, and also apart from that, there is a read-only domain controller just to handle, so that each and every resources, in an Active Directory there are going to be thousands of computers or users, right? So you need to handle those authentication, and for a single domain controller, that is going to be very hectic task. So just for that, we have this the concept of domain, and then you segregate the resources as remembered in the last image. Yep. So now again, what this domain controller is, domain controller again handles the authentication and authorization, holds the ntds.dev file. It also runs certain protocols like Kerberos for authentication and LAP for querying the object, because it is essentially a directory, right? It also has the global catalog and also does the replication rights. And as I was mentioning, for fail-safe mechanism, we can have more than one domain controllers, and some of them are assigned with read-only domain controller like, where the objects are essentially read-only and we just don't write to those domain controllers. Next, please. So again, trees I have already mentioned that you have got like a parent domain and then child domain. So between those parent and child domain or external domain, they are going to be trust. So that's it about the trees. Next. Now what is a forest? In Active Directory, a forest is essentially a security boundary. So like in a forest, there are a few properties which you need to keep in mind. One of them is in a forest, the domain names are going to be unique. So if you if red.local and blue.local ever joins their Active Directory, the domain names are ought to be unique. Like you cannot have the same domain names across the two forests, because then there is the DNS is not going to work properly, right? Next slide. Yeah. So as I was mentioning trust. So trust by default, when you have a parent-child relationship, this is bidirectional, but yeah, you can also define unidirectional trust when you connect external forests to it. And like in a trust, you have the concept of the trusting domain and trusted domain. For example, suppose I trust upon you something, okay? So I'll allow that, yeah, I am trusting you, so you can access some of my resources, right? As you trust your friend that, okay, you can have something from my cupboard in a similar way. And also there is going to be forest trust, which is by default. You can define shortcut trust. Can move back to that image, Active Directory image. Yeah. So in case of shortcut trust, what you can do is you can define trust between uk.red.local and dev.blue.local, because you might want that why uk.red.local will access the blue.local local domain, right? So you can explicitly define those trusts. Now organizational units. So organizational units are essentially containers where you are organizing either the users or the computers in that domain. And why you do so? Because see, in India, red.local, it is going to have some HR department, some developers department. Now using these organizational units, you will be separating out those components, and then on those individual components you can apply group policies. Now there will be an important concept that will come up. So yeah, group policies are something basically policies that you apply on an object, like an OU or an object that you want to access some resources. Like I'll give you access to certain resources, I'll deny you access to certain resources. You can change your wallpaper or not in an organization. That is all handled by these group policies. And then coming to containers. So containers are again similar to OUs, but containers are the objects where you cannot apply the group policies. So just keep this thing in your mind. Next. So yeah, so containers are something like in an Active Directory you have got organizational units, right? So in an organizational unit, you are putting down the objects, be it users or computers, right? So containers are again like organizational units, but these are the organizational units where you cannot apply group policies. And when you install an Active Directory, you will find that there are built-in containers and default containers, so on and so forth. So again, there are multiple protocols that the Active Directory works on: are DHCP, DNS, SMP, NPDNS, LLMNR, and there could be experts for each and every one of them. But then again, this is a 1 hour session, so we cannot cover each and every protocol. So I've skipped that part. Let's move on to the attacks. So now coming to the common attacks. Okay. So the first attack which we are going to talk about is password spraying, pass the hash, pass the ticket, and overpass the hash. Now keep in mind that password spraying, this you can consider as an Active Directory attack or you cannot consider as an Active Directory attack. That depends on you. But yeah, password spraying is something that you are generally going to find very common in Active Directory, because when you join in an organization, what you will be handed over is default account, or there will be some password, based on the password policies, the users, they create certain accounts, and then sometimes the users don't change their account. So if you spray those default credentials, there could be chances that you gain access to certain accounts. Or there could be some documentation. that okay, this is the password policy. You log into or you gain access to some file share where you find that okay, there is a file which defines the password policies or default password for this user, and the user is negligent enough or they haven't checked their mails enough that which alerts them that you should change their password. So there could be scenarios where you have a default password. Yeah. So for password spraying, like for the first 4 attacks, I won't be demonstrating them because like it's going to take much time, and these are easy to understand. So in case of password spraying, what we do is like there is this tool called Mail Sniper and Spraying Toolkit. You can use them. We first of all import the Mail Sniper module, and then what you can do is you can enumerate the net bias name, because like each and every domain is going to have their own unique net bias name. Okay, so you will be enumerating the net bias name. You will be using this name match script to gather all the names of that domain, like all the users which are there in the domain. I would like to show you how that is done. So for example, yeah, you can see this, that this is this cyberbiotic domain, right? Cyberbiotic.io. Now the team is going to have, like we have Bob Farmer over here, then there are going to be multiple users like Isabel Yates, John King and Joyce Adams. So what you can do is you can pick up these names, and then you can place these names into that file names.txt slide. Yeah. So you can place those names into this name.txt file, and what will happen next is like it will create the names pattern. Like in an organization, what you are going to see, the naming pattern is going to be either first name dot last name, or f last name, or f dot last name, or last name dot first name. So these all patterns it is going to generate and put it into that possible file. Now what you are going to do is you are going to use a timing based attack, and using that timing based attack, it will eventually find out which of them was the valid like usernames, and then it is going to place that name into this valid.txt file. So like previously you can remember that we have found the net bias name. So the username for that domain is going to be like the net bias name slash and then the valid username. Okay. And now what you need to do is the last step is going to be use the invoke password spray module, and then we spray the credentials onto that domain. And as you can see in the result, like I have used this invoke password spray on this mail.cyberbiotic.io. Obviously this is within a lab, and using the valid.txt password and the password of summer 2022, I found out that the password of Isabel Yates is summer 2022. So we just used a single password and we sprayed across multiple users. That is the concept, that you take in a single default password, you spray it across multiple users. Now you can also spray it across multiple protocols. For example, over here I just sprayed it over like mail server, right? You could use something like trackmap.exec or netexec, like which is now netexec. So you could use that, and they spray those credentials over SMB protocol, or WinRM protocol, over SSH, and then try to find out if like you have got access to certain protocols. Okay. So the next attack is going to be pass the hash. Okay. Now what is this pass the hash module? Like we are going to understand the NTLM authentication at first and then get back here. So like first next up. Ali. Yeah. So in NTLM authentication, what happens is like you have got this mechanical client, you have got this server, and you have got this domain controller. Okay. Like the domain controller handles authentication by both mechanisms, NTLM or like it could be controls as well. So in case of NTLM authentication, like the client has got the user's NTLM hash and the domain controller has got the NTLM hash saved into it. Okay. Now what the client will do is the client first sends out an authentication request to the server that I want to access your resources. What the server is going to do is it is going to send out an NTLM challenge, and then the client is going to encrypt the challenge using its own NTLM hash and create a response and send that NTLM response back to the server. Now the server knows the challenge, the server knows the response. The server in no way knows the NTLM hash. What it will do is it will send the challenge and the response to the domain controller. The domain controller will then use the NTLM hash and encrypt the challenge that it has received, and and then it will compare the response to the response that we generated initially, and then based on if our responses matches or not, like authentication will be allowed or denied. Okay, let's go back. Yeah, so pass the hash is the technique that allows you to authenticate to Windows servers using NTLM hash of a user password. Now, how are you going to get this NTLM hash? Probably you are going to compromise some machine, and then you will be getting access to the credentials using Minicat. Again, this is not like I'm not talking about it from a red teamer's perspective, because from a red teamer's perspective, if you talk, then touching the LSAS process should be the last resort. As soon as you touch the LSAS, there are going to be alerts and you will be picked up. So that is the last resort. But yeah, like if you gain access to a user's NTLM hash somehow, then what you can do is you can create a fake session, and then in that session you can inject the user's NTLM hash, and then when the server or that session where you created that will interact with the server, it will interact using the NTLM hash. Okay, that is how the pass key hash attack works. And like there are two common ways to do it. You could use the invoke mimikatz module, and then you'll use the security module and pass the hash. You specify the username, you specify the domain, the NTLM hash, and then what you want to run. It could be PowerShell or something. So a PowerShell session is run with a fake session, and then the NTLM hash is being injected into that. Also, like this command, this is actually the covert strike command. That because like if you guys don't know, then covert strike is essentially a command and control framework. And what that command and control framework does is, like it allows you to manage your sessions effectively. Okay, and it like you don't even need to remember these commands. Like these generally they simplify the commands. Okay, so next step. So like as you can see in the demo, like I checked the get UID and seen that I'm currently dev farmer and I don't have access to the C drive on web.dev.cyberbot.io, which is the web machine. Okay, you can see access denied. Now what I use is I use the pass the hash module. I specify the username and I supply the NTLM hash of the user. And what you can see is beneath, like in between, it is going to use the mimikatz module underlying in this underlying mechanism, and then it is going to create a fake session. And you will be impersonating. Can you go back to the previous slide? So, oh sorry, I haven't added that. But previously you did not have impersonated that. But once you impersonate a user in covert strike, you essentially find out that this is the place where the impersonated session's username appears. And now in the next step, when I'm trying to list out the C drive on web machine, I'll be able to list it out because I have impersonated J-King, and J-King is a user of that web machine. Is it clear? Next, coming to pass the ticket attack. Pass the ticket attack is an attack where instead of injecting these NTLM hashes, what we are trying to do is we are trying to get the TGT, Kerberos TGT, and then we are going to inject those into session. So again, what you could do is you could use the Ruby strategy module to gather all the tickets, but make sure in mind that you can just read your own tickets. If you want to read other users' tickets, then you need to have a local administrative access on that machine. Okay, that is the way how you would read other users' processes or stuff. And once you know the you will use the Ruby strategy command to see what are the LUIDs or local unique identifiers of the processes, what are the user names, and then what are the services. And using the next information, you are going to dump the hash and previous slide. So you are going to use the Ruby's dump command. You will be specifying the local unique identifier and then the service. And node is just a flag so that there are no lines breaks. And then you are going to create a read-only process and then inject the fetch TGT. So as you can see, I am using Ruby's triage command. Next slide. And you'll have a window like this, where you will be having the locally unique identifier, the user names, the services, and from here what I see is this J-King user. This sounds interesting to me. Make a note of it that I am running it from system beacon, so you can see the PID is 2656. I am running it from system beacon. Okay, and what you see is I have this fluid of time I use this fluid, I use the username of checking, and then I'll be getting the KRB TGT hash to dump Jenkins TGT. Okay. And once I have that TGT, I'll try to dump it using the flu-based dump command, as you can see, and I get hold of the TGT. Once I have that TGT, I create a net-only process. Again, a fake process I'm creating. That has got a PID of 16920 and this fluid. And then into that new fluid, I'm going to inject the TGT of that user JK. And then I'm going to steal the token of this new process that I created, and voila, I'll be able to access the resources in this web share again. So we saw that using pass the hash technique, we were able to access a machine. We also saw that using Kerberos tickets, we were able to access a machine, right? Next slide. Now overpass the hash. This is again a common technique because see, in order to dump the hashes, you need local administrative access on a machine, right? But to ask a TGT, you don't need. So using an NTLM hash, what you could do is, again you could use the UBS ask TGT module and you can get a Kerberos TGT, and then the process remains the same. You can inject that TGT into the session. So like using the UBS ask TGT module, I was able to gather the TGT and for this JK user. Then sorry. Oh, I guess I haven't added that. But that is how it works, is you have got this TGT and then you are going to inject it into a session. So you are seeing a pattern, right? You are creating a fake session, you are getting the NTLM hash or you are getting the TGT and then you are injecting those TGTs into those sessions. Is it clear so far? Next. Next slide. Yeah. Now, this is the part which is the most complex. So, like this Kerberos authentication, this is going to haunt people for days, I know. Like if you are seeing it for the first time, things are going to wind up. But just understand the process, how this authentication is happening. Again, you have got a workstation or a user computer. You have got this KDC role, which is installed on the domain controller, and then you have got a server, for example a web server or file server, from where you would like to access certain resources, right? So how the authentication is handled over here is, you are going to send out an authentication server request to the Kerberos KDC. The authentication server is going to send out to you an authentication server response where you will be getting the TGT. Okay. Now in the next step, what you will do is, you will use that TGT to request a TGS, which is a ticket granting service ticket, and then the server will respond you back with a TGS. And then using that TGS, you will be trying to access a server, and then the server will give you access to that resource. Now you can see, like TGT is requested once per login session, and like once you have that TGT, you will be using it to access service. Whenever you want to access a service, you will be like getting a TGS specifically for that service. Okay, next slide. Sorry, previous slide. Yeah. So now let's take a look at it at that. What is happening? What is Zoom left side. So as I mentioned, there was this authentication server request and the authentication server response. So in the first step, in the authentication server request where you are requesting the TGT, what you are sending out is your username and the timestamp encrypted with the user's NTLM, like user's hash. Okay. And once you send out this to the KDC or the domain controller, what the domain controller is going to do is, it is going to verify the timestamp using the user's hash. Also, there is one more thing that we are going to take a look at, the attack, which is ASREP roasting, where this verification does not take place. Okay. So getting back over here, so you are sending out your timestamp encrypted with the user's hash. The server is going to verify the user's hash and then using the KRB TGT user's hash, and you have the session key, okay, which is being encrypted using the user's NTLM hash. So the session key is encrypted using the user's NTLM hash, and when you come to ASREP roasting attack, this part will come in handy because a part of the response is encrypted using the user's TLM hash, and this verification does not take place. So in ASF roasting, we will be exploiting this part. And like once you have the TGT, what you can do is like you have got the session key, right? So in the next time you will again send the username and timestamp encrypted with the session key and TGT and the service name SPL or the service name, service principal name of the service that you want to access. So you are requesting a TGS, and the KDC, the next step, will send you a response TGS which will be encrypted using the service owner's hash. Okay. So in ASF roasting we generally exploit the TGT, and in curve roasting we exploit this TGS part in order to get the service owner's hash. And at the last step, what we do is once we have the TGS, we send out the TGS with the service session key to the service in order to access the hash. Okay. Any questions so far? Okay. Next. I know this might be you guys. So let's talk about these curve roasting, ASF roasting, constraint delegation, unconstrained delegation, desync and golden tickets. Okay, I guess we'll be out of time if we talk about ACWs. Let's move to curve roasting. So what is curve roasting? Curve roasting is a technique for requesting a TGS for a service. Okay. So remember the authentication mechanism. We requested a TGT, right? And then from the TGT, the next step what we got is a TGS, right? So using this curve roasting technique, what we will try to get is, we will try to get a TGS, and then we will try to crack that TGS in order to get the service account's password. Okay. Because if you remember the diagram, we had a web server, or a file server, where essentially the roles, for example in a MySQL server, okay, there is going to be explicitly a service account, and if we gain access to those service account, they generally done with high privileges. So you can use the AD search module, where I am looking out, in this specific case I am running an LTM query to query for specific object users where there is some service principal names associated. So we are essentially looking for service account. And then in the next step, what we can do is, we can use the curve roast module, and we can specify the individual users, in this case MySQL service account. And then once we have got access to this hash, what we can do is we can simply crack this hash. I'll be showing this demonstration to you guys once. So, is this visible? Okay. Now the scenario is that you have access to this is a Cobalt Strike C2. So you have got access to this C2, and over here you are you have a domain user account. Okay. If you want to perform an Active Directory attack, you need a domain user's credentials, and you will need a session with that domain user's identity. Okay. Then you can compromise the session. Now I'll be running the AD search query. Sorry. So what you are seeing is you have got this KRP TGT service account, you have got this MySQL SPC service account, and this Squid SPC and Honey SPC. Okay. From here, suppose I want to get the TGS for this MS SQL SPC account. So sorry, a silly mistake. I didn't like paste out the underscore of that user. So like let's like also have a look at the error. What was the error? Like the error was that we had a username. Like I pasted out the username, but in that error's case, the username was incorrect. So the what the error prompted out to me is that it is unable to query that user. If it's not able to query a user, or if that user is not present in that domain, how can we like essentially compose that user, right? So sometimes error are interesting as well.
So that error was related to LDAP, right? So
Yeah, the LDAP query, because essentially LDAP was
not able to detect the user.
Yes.
With your domain.
Yeah. So once you have it, once you run that query, you'll be essentially getting the TGS, KRB5 TGS, and then you can paste it into any text file and crack it using your cracking workstation. Now let's talk about ASREP roasting. Okay. So in ASREP roasting, we are going to essentially exploit the first two steps. ASREP roasting happens in a server where the Kerberos pre-authentication is not enabled. Like you have an explicit property, you check it, that do not require Kerberos pre-authentication. If that is the case, so whatever timestamp, username and timestamp you send it out, like the server is not going to verify that whether it is correct or not, but it is going to like send you guys back the response, and the response is going to be encrypted with the user's hash, right? So you can crack that hash again. So again, going out, we are querying out for users, and then for like searching out objects where the Kerberos pre-authentication is disabled, you'll need to run this query where once you run this query, you'll be getting out the users whose which accounts are essentially ASREP roastable. And again, the same thing, you run the UBS ASREP roast module and you specify the service account name and then crack it using John. So let's run this once. I guess I've used the previous command only, sorry. So essentially paying out for ASREP roastable accounts, we see that only this Squid SBC proxy user is the one which has got this, which is ASREP roastable. And then you get the ASREP roast hash. Okay, you can crack this hash again in John, and you'll have access to that user's credentials. Now coming to unconstrained delegation, one of the things which should not be there in the domains, but it is something which Microsoft has designed by feature. Okay, so what is unconstrained delegation? In unconstrained delegation, suppose a user wants to access the data web server, and then via the web server, the web server will try to fetch out that if the database user has the user can access the files or data on the database server or not. So how that happens is the IIS server or the server where this unconstrained delegation is enabled, that server will cache the TGT of each and every user that authenticates to it. So in case a user is authenticating to this IIS server, it is caching out its TGT, and then using this TGT, it is further on authenticating with the database server. What could be the implications of this? Suppose a user caches gets or compromises this IIS server, and ever a domain admin authenticates to this, you are getting the domain administrator's TGT. You can compromise the domain administrator account, and once the domain administrator account is compromised, it's a game over, because remember the old diagram. The entire forest is compromised if you had a domain admin's credentials. Okay. And by the way, this unconstrained delegation was introduced in Windows Server 2000. So again, querying out for servers where this unconstrained delegation is enabled. By the way, you can run it on users and computers both. Yes. Yeah, so what you can see is this DC2 and web server, both of them have unconstrained delegation. Now domain controllers have this unconstrained delegation by default, but this web server having this unconstrained delegation, this could have implications, because as we saw previously, somehow we compromised the jaking user, and jaking was an administrator on this web server. Okay. So if someone authenticates to this web server, essentially we can get that user's hash. And to add on to that pain, there is something called, we can force authentication using techniques like print spooler. So what we can do is, using print spooler technique, we can force the domain controller to authenticate to this web server and then get the domain controller's TGP. I'll be showing that to you guys. So,
just a question. So in that case, if your domain controller is forcing to authenticate this user,
yeah.
so in that case, do you really need that checking user its reference?
Sorry?
So your domain controller is forcing this authentication session to be authorized, right?
Yeah.
Showing. So in that case, you said you have some hashes from that checking user.
Yeah.
So you really need that, or it will be fine, without.
See, I need access to this web server, okay?
Okay.
So somehow I'll compromise this web server, for example, which has unconstrained delegation. I then don't need anything related to the domain controller. I'll force the domain controller to authenticate to this web server.
Okay, got it.
I'll show that demonstration. So in this case, I'll be interacting with the beacon for, yeah. So this is the beacon for the web server. So I'm running Rubius with the monitor command, and the interval is going to be 10 seconds. So every 10 seconds, if any new TGTs come up, it is going to show it. Okay. By default, obviously the domain controller is not going to authenticate to this web server. There will be user credentials. As we can see, that jaking has authenticated, so jaking's TGT is here. Web server's TGT is here, so on and so forth. Now I had this workstation machine, so I'll be using that. Just to verify, the P farmers beacon I am using. And using this shard system trigger. I am forcing the domain controller, this is dc2.dev.cyberfortic.io, to authenticate to web server. Okay. And as you can see, we have the DC2's TGT. So I guess you guys understood what we are doing over here, right? We had this we compromise the web server, and then we force the domain controller to authenticate to the web server, and once the domain controller authenticated to the web server, we had its TGT. Okay. By the way, like if you had a user account, you could directly use those TGT. But in this case, since it's a machine account, so you cannot like use tricks like S4U2 proxy. In this case, you will explicitly need to use tricks like S4U2 self to authenticate. Okay. So this is what we did. Now coming to constraint delegation. Constraint delegation is something like previously what we were doing, we were restricting the we were caching out the TGT, right? So in Windows Server 2003 onward, this concept of constraint delegation came in, where it aims to restrict the services to which the server can act on behalf of other users. It no longer allows the server to cache the TGTs of other users, but allows it to request a TGS for another user using its own TGT. So in case of constraint delegation, you essentially cannot cache another user's credential. But what you can do is, if you can use your own TGT to impersonate any other user or any other service. Okay. So in this case, like the simple thing could be any unconstrained delegations, like for example any server with like constrained delegation is compromised, you get its TGT and then again you use that TGT to compromise any other user, but preferably we try to compromise the domain admin because that is our go-to end goal. Once the domain admin is compromised, everyone understands that the entire domain is compromised. So sorry. So specifically looking for like computer objects where like MSDS allowed to delegate to properties set, and what we can see is this equal to this machine can essentially delegate to this SIF service, which is essentially a file service like on DC2. So this equal to can access files on the domain controller. Okay. Now the Jaking user fortunately had like administrative access even on this machine, like this SQL2. So in this case, what we can do is so running the ruby's hash command, I can see that we have multiple hashes. Out of that, I'm trying to dump this hash. Okay. So we have got the hash. Now I'll use a S4 into proxy trick. Like I have got the nlab, which is the domain administrator. I have got its hash, and using this hash I can access the DC2, like files on the DC2. So now I am using the before that I would like to show you that I don't have access to DC2. I couldn't access the files on this. I use this impersonated TGS. And then if I try to impersonate this process, now let's try to list down the files, and voila, we have access to the files on the domain controller. Now, like this was, we had access to the files on the domain controller, right? What we could do is, even in Ruby's S4U, there is one parameter called alt service, and since in this authentication when you send out an SPN, you essentially that SPN part is not being controlled, and it is something which Microsoft had designed it. So instead of accessing just this SIP service, I could specify an alt service, and then using that alt service what I could do is I could essentially impersonate something like LDAP and then perform things like DC sync, because in order to perform DC sync you need LDAP. So this was a quick demonstration. Now coming to DC sync, like DC sync, what is it? Like if you guys remember, I was talking about previously that we can have multiple domain controllers, and then there is going to be this replication rights, right? So this DC sync is how this happens. Like it uses the directory service replication, or MS DRSR, directory service replication rights, to synchronize the data between the domain controllers. And what you can do is, with any domain controller, domain administrator, or any account who has got this replication right, what you could do is you could perform the DC sync with this mimikatz lsnf DC sync, and then specifying the user whose credentials you would like to dump. Generally, we can dump any user's credential, but we love this KRP-TGT user. Okay, why is it so? Because the KRP-TGT user's hash is not changed by default. Okay, we can change any domain administrator's credentials, but we cannot change this KRP-TGT credentials by default. So you can again see that I use the get currently I'm dev v farmer. I created a token as nlab user. Okay, and I impersonated the nlab user. Let me do it for you. Currently I'm dev v farmer. Now I make a token for the user. So I've impersonated the user nlab, and it shows up in Cobalt Strike. Now what I can do is, I can use DC sync module. And voila, you have the KRP-TGT users in TLM and AES hash. Okay. Now once you have this KRP-TGT users and TLM hash, why I was trying to get the KRP-TGT users and TLM hashes? You could essentially perform a golden ticket attack, which is again a domain persistence mechanism, where a golden ticket is a forced TGT signed by the domain's KRB TGT account. A golden ticket can be used to impersonate any user to any service on any machine. So that's it, and to add on to the insults of the injury, the underlying credentials are never changed automatically. So again, you could use Ruby as golden module and then specify the user's NTLM hash, like whatever user you would like to impersonate, the domain and the set of that domain, and then use their node graph. And then, as usual, inject the ticket into that session. So this is how you would do that. And then injecting the ticket, I get a session as a headline. So that's it. Thank you.